back for lesson 2. That means today we know how to calculate the number of outcomes, because that's important. If we can't find the number of outcomes, probability and odds are extremely difficult because it takes the number of outcomes for those results to work. So in the lesson 2 here, we're going to talk about probability and odds. So let's get going. So the first thing we want to look at here is in probability and odds, a desired outcome is called a success. Any other outcome is called a failure. So if what I want to happen, I call that a success. Now, here's how we find the probabilities. Probability of success and failures. If an event can succeed in S number of ways and failures in F number of ways, then the probabilities of success, P of S, and of failure, P of F, are as follows. P of S is equal to S over S plus F. So, easiest way for me to write that or think about that is number of success over total. Okay? And P of F is F over S plus F. So, number of failures over total. Now, when it comes to probability, we might write that as a fraction. We might write that as a decimal. We might even write that as a percent because it's a probability. So any of those are possible answers when it comes to probability. What is the probability of something happening? You might do it as any one of those. Okay, so now we'll look about odds then. Odds, if an event can succeed in S ways and fail in F ways, same as probability, then the odds of success and of failures is as follows. Odds of success is S to F. Notice that is written as a ratio with the colon between them. How many successes, how many failures total? Odds of failure is number of failures to numbers of successes. So we don't worry about total. We only look at, okay, how many times did it work? How many times did it not work? If you ever happen to go to a racetrack or you watch simulcasting live or whatever, you will see the odds of a horse or an animal winning their race. And you might see a 5 to 1. Okay, if the horse ran 6 times, 5 times it would win that race, 1 time it wouldn't. A type of deal is what they're saying. So that's odds and successes. Okay, so part of our assignment is going to be something fairly simple like this. We have to find the odds of an event occurring given the probability of the event. Well, since this is the probability, this is success to total. So that means the number of failures has to be the difference between those. So 3 to, well, how many failures did we have? 4. This would be a 4 to, well, 5 minus 4 is 1. 5, 4 to 1. 2 out of 13% chance of happening would be a 2 to 11 on the odds. 1 out of 15 probability gives me a 1 to 14 for the odds. So that's how we do that. It's always success to total when we look at probability. Odds is success compared to failures. Okay, can you go the opposite direction? If I gave you the probability, find the probability then, if I gave you the odds. So if I had a 10 to 1 as my odds, what's my probability? That would be a 10 out of an 11. Easiest way to write it in this case. Okay, here we have a 2 to 5. That means I have 2 in total. I'm going to add those 2 numbers. A 2 to 7. 4 to 9 would give me a 4 out of 13. 8 to 3 gets me an 8 out of an 11. Okay, those are the easy probability type problems when you're given the odds because they told you how many successes and failures you have. It gets tough when you get a problem set like this. Oop, too far. Okay, one bag of candy contains 15 red candies, 10 yellow candies, and 6 green candies. Find the probability of each. Picking a red candy, just picking one red candy. Well, how many successful outcomes do you have? You would have 15 successful outcomes. How many failures? Well, let's see. There are how many total? We've got 25, 31 totals. So 15 out of 31 if I want to write it as a fraction. Picking a green candy. Well, that's going to be a 6 out of 31. It's always going to be out of 31 because that's a total. Not picking a yellow. Not picking a yellow. Well, how many things out there are not yellow? Well, that would be 21 out of the 31 outcomes. Okay, not picking a red. Well, how many candies are not red? That'd be 16 out of 31. So if we only have to pick one item, it's not that big of a deal. What happens if we get tougher problems? Like these. These, notice we're grabbing 3 candies at a time. Same bag of candies. And instead of just grabbing 1, we're grabbing 3. So in this set of problems, we're going to pull out 3 candies. So the first question I have is, how many different ways can we pull out 3 candies? Is that a permutation or is that a combination? And the answer is combination, because we're just grabbing them all at the same time. If I was pulling 1 out at a time, we could keep track of what color came out first, second, or third. But we don't care about that. We just want all 3 candies out. So that means we need to do a combination for total is a combination of all 31 candies taken 3 at a time. So you're going to have to be able to do that on the calculator. Or however you want to figure out how you're going to take a combination of 3 candies 3 at a time. And I typed in something wrong. Okay, there's 4,495 ways we can just grab in, pull out 3 candies, and just take a look at what we have. So what's our probability of grabbing 3 reds only? So we're going to look at the combination, and we're going to pull out 3 reds, and the combination of all 31 taking 3 reds, and we know the bottom's 4,495. So what do we get on the top? On the top is how many red candies do we have? We have 15. So let's change that to 15 taken 3 at a time. That's 455. We have about a 10% chance of getting 3 reds. Or if you want to reduce that down, 91 out of 899, it's around 10%. Okay, so what if we wanted to grab 2 red, or let's go with no reds. We'll do that one next. Okay, no reds. So I mean we have how many candies that are not red? 16 candies that are not red. Out of our total, 31 and 3. Okay, so now if we just take our same value that we had, our short combination, and we do 16, it says we got 560 ways or about a 12% chance that we would get no reds. So we got about a 10% chance we reach all we get is reds, and we got about a 12% chance of not getting any reds. Okay, so now let's look at the other 2. Now we have mixed bags here. How many combinations of each of these can we get? So now, when we set these up for our probability, the number of successful outcomes has to match up to this. I've got to get the 2 reds and the 1 yellow. That should be a 1 out of 6. That's a 1 yellow. I must have looked at how many yellows we had. Okay, so I'm going to grab 2 reds and 1 yellow. If it's a 6, our answer is 0. Because we're only pulling out 3 candies. Okay, so that's why we're going to make this a 1. That's a 1. 2 reds and 1 yellow. Okay, so I find out the reds. How many ways can I get the 2 reds? That's a combination of 15 of them, taking 2 out at a time. And the yellow is the combination of all 6 of them, taking 1 out at a time. And then what I do is I multiply those two quantities together, and then I put that over the whole 31 comma 3. Now notice, here's what I want you to notice. These two numbers at the end of our parentheses have to add up to be the number in the bottom as well. I can only take the same number of quantities total. That's what we want to make sure we match up there. So now we just got to figure out what each of these values is. So what is the combination of 15 things taken 2 at a time? So if you happen to watch my little quick video on Pascal's triangle, I could just go to that row 15, go into the third number, and that would be it. That'd be 105. So we're down a way. We've got to go down 15 rows. Okay. Combination of 6 things is 6, and then we still have the 4495. So we have 630 over the 4495. That's about 14%. We have a higher chance of getting 2 reds and a yellow than we do of getting no reds or all reds. What did I say? That was 630 over 4495. Okay, now what if I want to do a combination of one of each colors? Okay, we still know on the bottom it's still the 31 comma 3. On the top we have the reds. So I've got the 15 comma 1, and I have the greens, which would be the combination of 10 comma 1, and I'd have the yellows, which is a combination of 6 comma 1. Now here's the thing, and again I kind of pointed this out in the Pascal triangle video. If I'm only doing one of the item, the number of items I have is how many outcomes. So that gives me a 15, a 10, and a 6. I would just multiply all those, and then it's going to go over the 4495. Well, if I multiply all those, I get 900. That's our highest value over the 4495. So I guess there's about a 20% chance of pulling one of each color out rather than any of the others. Now, what could we do if we didn't want to use the combinations? We could have made a tree, and we would have had to, in our tree, account for all 4,495 outcomes, which would have been a real pain in the biscuits. But that we could have done it that way too. Okay, so that's what your assignment's going to be about today, is finding these probabilities. So, you're ready to get on it.